A cup filled with 20.82 grams of ethanol, initially at 95.4 degrees Celsius, is poured into another cup with 72.5 grams of water at 23.3 degrees Celsius. What is the final temperature in degrees Celsius of both substances at thermal equilibrium when all temperature changes are complete? So this is, quite literally pouring two things together. And if you have something that's hot and something that's cold, then the final temperature is going to be somewhere in between these. So, and we don't know where it is. That's what we're going to solve for. And it will be the same temperature. So both the ethanol and the water will be at the same temperature. And this is what's called a coffee cup calorimeter problem. With two materials. And it has a different set of equations. But the base idea is that Q sub E, which is going to be for my ethanol, is equal to minus Q for my water. And you can see that's actually very similar to the when there was a reaction involved. A Q is still equal to a negative of another Q. But now both of them, so both materials change temperature. So, and there's no reaction listed, and there's no reaction that occurs. And so, because one of the hard things is telling which set of equations to use. Now, what that means is that each of these terms, so QE is going to be mass of ethanol times specific heat. Sorry, specific heat is C. Let me start over again. Mass of ethanol times specific heat, which is C sub S, of my ethanol, times my delta T, which is going to be T final of my ethanol minus T initial of my ethanol, is equal to the negative of the exact same thing except for water. So mass of water, specific heat of water, T final water minus T initial water. And now it's a lot of variables, but all of the variables that all of the values that we need except for one and are in this problem. And so let's go ahead and fill them in. So the mass of our ethanol is given as 20.82 grams. My specific heat of my ethanol is given as 2.46. joules per gram degree Celsius. And actually, I think on some other problems I used 2.42, so watch out for that. But sometimes it's different. And again, I probably just got them from different sources. And T final, well, now let's talk about T final. It says, what is the final temperature of both substances at thermal equilibrium when all temperature changes are complete? So my two T final values are the same because they meet at the same temperature. So I'm just going to call that T final for both of them now. And then my initial temperature of my ethanol is given as 95.4 degrees Celsius. And then we'll do the same thing for my water. Don't forget your minus sign. But I have 72.5 grams of water. My specific heat of water is given on my conversion and equation sheet. It is 4.184 joules per gram degree Celsius. And I don't know if I'll have enough space in here, but T final, I don't know. And T initial is 23.3. Sort of fits in there. And now we're off to what I like to call the Algebra Olympics, because the only thing to do is, if you whether you call this T sub f or x, there's one thing you don't know, and everything else is just math. But let's go ahead and work this out. All right, oh, I lost it there. There we go. So the way I tend to work these out is I will multiply these two numbers together. 20.82 times 2.46. That's going to be 51.2. And it's going to be 51.2 times both of these terms. So 51.2 times TF minus 51.2 times 95.4. And I get 4,886 equals, minus sign, don't forget that, these two numbers multiplied by each other, 72.5 times 4.184 is 303.3. So it's going to be minus 303.3 times T sub f, and then minus a minus, so it's going to be plus this 303.3 times our 23.3. And this time I get 7,000, well, I'm just going to round it to 68. So we're getting there. Now we have our TF terms and our numbers. So I'm going to move my 303.3, my minus, over to the other side by adding it. To both sides. And as long as I do the same thing to both sides, it stays equal. And then I'm going to add 4886 to both sides. And when I do that, this term cancels. This term cancels, and I end up with my T sub f terms on one side and my numbers on the other. So 303.3 plus 51.2. What? Oh, I must have subtracted 303.3 plus 51.2. There we go. 354.5 times T sub f equals the sum of these two numbers. $11,954. Divide through both sides by 354.5 to get T sub f all by itself. And I get to 3 sig figs, a final temperature of 33.7 degrees Celsius. And that temperature, I would say, does make sense because it's between our two initial temperatures. And then furthermore, you can see that I have more mass for my water and a higher specific heat capacity. Both of these terms will tend to make the final temperature closer to the temperature that the water started at. So the fact that this is closer to 23.3 is because we had more mass of water and a higher specific heat for water. And those are more mass of water than the mass of, actually we had almost 3 times, we had more than 3 times the mass of the water than the ethanol. And our specific heat was, well, not double, but certainly larger. Let me see if I can get the whole thing on screen. At least the answer part. Any questions about that? Okay.